Unlike conventional methods, which only provide surface level or two-dimensional images, Voidsy technology delves deeper and provides three-dimensional results that also allow conclusions about the depth of a defect.
Welcome to a new episode of our inVISION podcast, 5 Questions 2. Our topics are image processing, machine and embedded vision, AI and metrology. My name is Peter Ebert, Editor-in-Chief of inVISION, and I'm happy to have you here for a new episode. The Austrian company Voidsy was recently named inVISION Startup 2024. That's why inVISION talked to Holger Plasser, CEO and one of the founders of the company, about their new technology. He will introduce us to photothermal tomography, how it works and what is it good for. Hello, first of all, once again, congratulations on being named inVISION Startup 2024. Perhaps you could briefly introduce us to the company Voidsy.
Thank you very much. We are thrilled to be awarded as inVISION Startup of the Year 2024. Of course, I can introduce to the company Voidsy. Voidsy specializes in advanced non-destructive testing systems tailored for the inspection of composite materials used in aerospace structures. And our core technology, the 3D VROX photothermal tomography system, offers a fast, contactless and imaging-based approach for detecting potential defects, ensuring high-quality standards are met. And this system is versatile, supporting both production and also MRO, maintenance, repair and overhaul applications. And we're committed to pushing the boundaries in non-destructive testing to deliver innovative solutions for the aerospace and broader industrial markets. So Voidsy is a spin-off of the University of Applied Sciences, Upper Austria, and a quite young company. Voidsy was founded in 2022, but the 4 co-founders, Günther Meyer, Gregor Tomra, Gernot Meyer, and me, are working together and doing research in the field of NDT and active tomography since about 15 years. And our research work led to a clear identification of the user requirements for the technology from the industrial side. And after completing our PhDs, we decided to go straight into sensor development and develop the 3D VROX photothermal tomography system.
And maybe you can explain to our listeners, how does photothermal tomography work?
Sure. The smart and compact 3D VROX system incorporates cutting-edge technology to enable, for the first time, photothermal tomography, which is physically based on the method of active tomography. And in this method, energy is introduced into the component on the test to bring it out of the thermal equilibrium. And with the 3D VROX, the radiation from the optical excitation sources is absorbed on the component surface of the component, and the heat propagates into the material. If the thermal wave now encounters an internal defect, for example, a delamination in CFRP, this thermal wave is reflected to the component surface, and at this point, the wave already carries information about the internal structure. So during the entire process, the surface temperature is measured over time using an infrared detector. Using our post-processing, we solve a ill-posed mathematical inverse problem and calculate the internal structure based on these measured surface temperatures versus time. And unlike conventional methods, which only provide surface level or two-dimensional images, Voidsy technology delves deeper and provides three-dimensional results that also allow conclusions about the depth of a defect, and that is why we call it photothermal tomography. With our evaluation software, customers also have the option of displaying and analyzing measurement results from the 3D VROX in usual ultrasonic representation, such as the A, B, or C scan, well known from ultrasonic testing.
And what applications can your system be used for?
So industries such as aerospace and automotive greatly benefit from Voidsy's non-destructive inspection technology. For instance, in aerospace, where the integrity of materials is paramount, the 3D VROC system allows for thorough inspection of composite components, ensuring structural reliability and safety, for example, in the detection of delaminations, disponds, or also porosity in composite structures. And in the automotive industry, where production speed and efficiency are crucial, the system's rapid scanning capability enables faster quality assurance processes without compromising accuracy. And these sectors leverage Voidsy system to enhance their manufacturing quality, ensuring that each component meets stringent safety and quality standards. So in both market segments mentioned, we also have observed that the compact design of the 3D VROC system plays a significant role for our customers. The system's compactness and the lightweight make it easy to use in mobile applications, for example, in product development or on mobile on-site applications. And on the other hand, the compact design enables simple automation, which is necessary, for example, for the automated inspection of complex shaped or very large components.
Okay, now we heard a lot about the applications, the advantages of your system, but what are the limits of the technology?
Yeah. While photothermal tomography with the 3D VROC system is highly effective for a wide range of applications, like any technology, it has certain limitations, right? And the technique relies on heat diffusion, which means that material with low thermal conductivity or thermal diffusivity or very thick components, or those with highly complex internal geometries, may pose challenges in detecting certain types of defects or in achieving high resolution at the deeper level. Additionally, also environmental conditions such as very high ambient temperatures or external vibrations can impact the precision of the measurement. Also, these effects can often be minimized with a careful setup and calibration. Another consideration is that the photothermal tomography primarily detects subsurface flaws near or moderately deep beneath the surface. It may not reach the very center of particularly thick materials. Nonetheless, for materials with moderate thicknesses, and this means up to 50 millimeters in monolithic CFRP and most composite structures, the 3D VROC system provides very clear and reliable insights, and ongoing advancements continue to extend its capabilities in challenging environments and materials.
Maybe we can have an outlook. What will be next? What new developments can we expect from Voidsy next?
Sure. Looking to the future, Voidsy is committed to continuous innovation and expansion of its product line. So first and foremost, we are working on the series production of our photothermal tomography system, 3D VROCs, in order to make it widely available to our customers from Q1 2025. And at the same time, we are actively working to expand our market presence, particularly in regions and also industries where our technology can fulfill unmet needs in non-destructive testing. In the midterm, we are planning further hardware variants to specifically cover the spectrum of different material systems, plastics, as well as metal structures, before we plan to use our software and post-processing algorithms independently of various hardware manufacturers in the long term.
Holger, thank you very much for this podcast. We wish you a great success with your new technology for the future, and maybe we have once again another podcast here.
Thanks for having us and have a nice day. Thank you.
Bye, Holger.
Bye.
If you would like to find out more about inVISION, please register for our inVISION newsletter at invision-news.de/news, become a follower of our LinkedIn channel inVISION News, or find out about our webinars at invision-news.com/Tech Talks. I look forward to welcoming you to our next episode of our inVISION podcast, 5 Questions Too.